thermometric, they are just called thermometric substances. You understand? When they say thermometric substances, if you are making use of your thermometer, for instance now, thermometer has its own thermometric substance, like mercury. You call it what? Mercury in glass. Do you understand? Your mercury is being found inside that glass. It is the mercury which that stands as the what? Thermometric substance. So don't be surprised if you are being asked what is the thermometric substance of a thermometer. It is what we call mercury. You understand? For another structure, for another structure that is being used to measure thermometer, they can have their own thermometric substances. Let's say, for instance, we have. But before we go into all that, let's start from the beginning. What is temperature? What is temperature? Temperature is defined as the degree of hotness and coldness of a body. Remember, we spoke about heat, because you must be able to differentiate between heat and temperature. You must be able to differentiate between heat and temperature. What did we say heat is? We said heat is the actual what? Flow of temperature change. You have to note that heat is the flow of what? Temperature change. Are you seeing it? Is the flow of temperature change. When temperature changes is flowing, then heat is being what? Noticed. But what is temperature? Temperature is the degree. Is the degree of hotness and coldness. Of hotness or coldness of a body. Is the degree of hotness or coldness of a body. It means that if a body is becoming too cold, more than the initial level of coldness, it means that temperature is experienced. You know, in our own side of the world, or in this side of the world, or in the layman language, when they say, she's having temperature, a lot of people will say, she's going hot. No, it's not only about going hot, it's not only about the hotness. Coldness, when the body is undergoing another structure or higher level of what? Coldness. We say that body too is still experiencing change in what? Temperature. And that's the degree of what? The coldness. Now, let's go to the continuous description of what? Temperature. Temperature is a phenomenon that occurs around us on a daily basis. As long as there is a change in the atmospheric condition of the place, there will always be what? Existence of temperature. What do I mean? The atmosphere itself that surrounds us analyzes or gives us the what? Give us the temp. What do I mean? I'm talking about our what? Atmosphere. It's the atmosphere that surrounds us that makes us what? Have what? This change in temperature, which means that when you have your what? We have two seasons. We have the rainy season and we have the what? The dry season. Now, the rainy or the what? The hot season or you understand? The dry and the rainy season. Now, these two regions will experience different what? Level of temperature. Naturally, during the rainy season, most of what we experience is the what? Coldness. You understand? Most of what we experience in terms of temperature change is what? Coldness. Now, during the dry season, we all expect it to be what? Very hot. So, the atmospheric condition of what? A place determines the what? Temperature change. So, let's proceed to measurement of temperature. What instrument do we use to measure temperature? I mentioned it earlier. We thought the main instrument is what we call your thermometer. And your thermometer has different types. Do you understand? So the major instrument used to measure your temperature is your what? Thermometer. Now there are various types of thermometer with specific thermometric substance. In our graph there, we have like 5. I gave five different types of what? Your thermometer. Number 1, we say we have your what? Liquid in glass thermometer. Liquid in glass thermometer. We say we have the liquid in glass thermometer, which uses your what? It uses, we have the what? Thermometric substance, and we have the actual thermometer. 5 types of thermometer with what? Their thermometric substance. That is, the substances that are found in them. Do you understand? What do you mean by thermometric substance? A substance that helps what? Brings about that indicator each time what? Temperature change is experienced. Liquid in glass thermometer. We have what we call the constant volume. Constant volume thermometer. we have what we call the pressure thermometer. Now, before I proceed, you need to look at what are all these what are their thermometric substances. For liquid in glass, their major thermometric substance is mercury. When I say thermometric substance, I've said it before. If this is to be your thermometer, now thermometer is calibrated like this. If you look at it, here you might have your 0 degrees Celsius. No, here you have maybe your 100 degrees Celsius, maybe 80, maybe 40, maybe 30. Now there is a liquid that is inside this thermometer. Now that liquid is what we call your thermometric substance. So for your thermometer now, for your liquid in glass thermometer, your thermometric substance is what? Is your what? Mercury. So this mercury is what? The major substance that is very sensitive to what? That temperature change. If the temperature is high, it goes up. You understand? It goes up to probably 50 or 60. That is why when one is running temperature, then you insert the thermometer in the positive armpit, you see a what? A very high temperature change. Now that is under liquid in glass. Now under your constant volume thermometer, we have our thermometric substance as well. Under our constant volume, we have our thermometric substance as pressure in gas. Pressure in glass. That's just thermometric substance. Now, we have also another one, thermocouple. We have our thermocouple. Thermocouple is a type of thermometer. So all these, we already have it there at the graph. All these are the major type of thermometer and their thermometric substances. So let's still proceed. Now there are various types of, we've discussed that. Now let's go to thermal expansion. Thermal expansion of solid and what? Liquid. Now for our thermal expansion of solid and liquid, what do you mean by thermal expansion? Let me break it down. Thermal expansion of solid and liquid. You see, every particular topic in sciences, they are so interesting that each of those words, immediately you can break them down individually, you don't have any issue. It's also very good to imagine things. When you say thermal expansion of solid, and thermal here means what? Heat. You understand? The situation whereby heat is being incidented on both solid and liquid. The situation whereby heat is being incidented on both solid and... Now when you say expansion, when you have your solid, one thing you need to understand is, for every body, I'm not talking of human being, for every single body that has heat being incidented on it, no matter the number of time, do you understand? No matter the number of time, this actual heat is used to incident on this body. This body normally undergo what we call expansion / contraction. I will explain those two in English. Expansion / contraction. When I say expansion is when it's what? Changing in its size positively. When I say positively, if this is to be the actual length of what, let me say iron now for instance, is now being subjected on heat. Do you understand? Heat is now being subjected on it. Now, the actual length of this particular what? Body, which is a metal, let's say the length is L1. This body will tend to what? Increase its length to an extra, let's say E. Do you understand? This is E1. Now, the total length of this particular body, after it might now be extended, it will now become L2. Meaning that there was an expansion. Do you understand? There was an expansion from the initial length of this body to what? An extra length. Now, there is every possibility that immediately the heat is actually being removed. Do you understand? It will contract back. Contraction means returning back to its position. Expansion is increment in what? In size. Right? Now, why your contraction is what? Decrement. in size. When I say decrement, that is that longer length which it went to. Do you understand? Now, due to removal of that heat, it might what? Reduce to its what? Initial position. But scientifically, each time an object is being what? Extended in terms of whether heat or whatever. If whatever you are now incident on that particular material is being removed, returning of that material to initial length will never be to the what? Actual length at which it left. What am I saying? You hit on, okay, let's take for instance your rubber. Let's say a rubber now is being incident with heat, and due to you now notice that there is an expansion. You even now remove the heat, it has expanded. Even if you contract back, it will never return to what? The initial position or the initial actual structure of that rubber. So with all this analogy, I want to believe the actual meaning of what thermal expansion has been gotten. Let's now look at let's start with solid. A solid is any what given body which has a rigid external surface with constant position, which constitutes what? Molecules bonded by what? Strong intermolecular forces. Don't mind those my grammar there, but you need to what? Put in some kind of scientific what? Explanation of what you meant. If I say intermolecular forces, a solid is anybody that has what? A lot of atoms, atoms of molecules situated into it. But those atoms of molecules are static, they are not moving. And they also have what? Strong intermolecular what? Forces bounding the two what? Atoms. Very strong ones. So that is why they are what? Solid. Do you understand? The further description there says that solid expand when heated and contract when cooled. But different solid material have different rates of what? Expansion when heated. What do I mean? This is a solid. Let's say this solid is, let me say a brass. A brass is a material. I have another solid here. Let's say this is a copper. This is copper. I have another one here. This is what? Aluminium. The three of them are solid, right? But if it is being subjected on the tree, the rate at which the tree will what? Expand differs. That is, they all have different what? Different level of what? Expansion when being subjected